So let's take a look when I've got a fraction. Now here we've got 25 hundredths, which is the same as 1/4. So this is our parent function. So this is g of x equals 25 hundredths x. Now, I don't have an a value here, but I do. It's negative. So that means my a value here is -1. So what's going to happen if I put a negative in front of this? So let's see. I'm going to pick -2, -1, 0, 1, and 2. So if I have negative 25 hundredths to -2, well, that's the opposite of 1/4 to the -2, which means I have -4 squared, which gives me -16. Because 1/4 is the same as 25 hundredths. If I take a look at 25 hundredths to -1st, I end up with, again, 1/4 to -1. So I end up with -4 to the first, or -4. So got -4. Now watch your zeros again. So if I have negative 25 hundredths to the 0, that is 1. So I end up with -1. Here we're going to end up with -1/4, and here -1/16, because they are the opposite, or I should say the reciprocal, not the opposite. They are the reciprocal. So let's take a look then. If I've got -2, -16, -1, -4, 0, -1, 1, little and even smaller. Now, I'm never going to get to 0, but it's going to get pretty darn close. So what's the difference between these graphs? Well, my original goes up. This one is a reflection in the x-axis. So my points are just the opposite here. So the graph of f is a reflection in the x-axis. So here's the info I need. It's a reflection in the x-axis because it flipped over the x-axis. So it's a reflection in the x-axis of the graph of g. Now, I still need to find the domain and range. The domain, well, what can my x values be? Real numbers. I can pick any value for x I'd like. And then my range, what's my y value? Well, my y value is always going to be less than 0. I'm never going to reach 0. I'm going to get pretty darn close, but I'm not going to reach it. So we've talked about this equation here for an exponential function in the form of y equals ab to the x. The y values change by a factor of b as x increases by 1. So you can use this fact to write an exponential function when you know the y-intercept. So if we take a look, now remember this 2 is the y-intercept. And the 5 is the common ratio. When I look at my x values, I'm increasing by 1, factor of 1. I'm sorry, it's just increasing by 1. It's not a factor of 1. Now here, it's increasing by a factor of 5. We're multiplying by 5. So if I wanted to write this, I've got y equals, now the y-intercept is when x is 0, so that's where this 2 came from, and I've got a common factor of 5. So you've got your 2 here, and your 5 there. So let's take a look. The graph represents a bacterial population Y after X days. Write an exponential function that represents this population. So all we're going to do is kind of rewrite these numbers. So I have 0, 1, 2, 3, and 4. So 0, 1, 2, 3, 4. I don't have room for 5. That's okay. So after 0 days, so I've got 3, 9, 27, 81, and 243. So you can see how quickly that's changing. Now, here is my y-intercept. Okay. Now, I need to find my common ratio. So multiply by 3, multiply by 3, multiply by 3, and multiply by 3. So here I'm changing by 1 and then multiplying by 3. So this is my common ratio. So if I have y equals a to the bx, a is my y-intercept, which is 3. My common ratio is also 3. So I've got this final equation. So given that equation, let's find the population after 12 hours and 6 days. But if I go back, I remember that x is days. And then y is the number of bacteria. Okay, we call it the population of bacteria. But the problem is this is in hours and this is days, so I'm good here. But what is 12 hours in days? Well, that is half a day. So if I'm looking for 12 hours, I'm still going to use the same formula, but I have to remember that x is in days, not hours. So I've got y equals 3 times 3 to the 1/2. Now remember, I can write that a variety of ways. I can do 3 times the square root of 3, or I can rewrite it as 3 to the first times 3 to the half, which is the same as 3 to the 3/2, which is the square root of 3 cubed. Either way, when I do that math, I'm not going to get a nice number. So when I find that out, I'm going to end up with approximately 5. So after 12 hours, we only have 5 bacteria, which really isn't a lot. But let's take a look at that 6 days later. So I have y times 3 to the x power. So y equals 3 to the 3 to the 6. So I end up with, now remember, that's 3 to the first, so I can combine those for 3 to the 7th. So y equals 2,187. So for 12 hours, I have approximately 5 bacteria. In 6 days, I have approximately 2,187 bacteria. It's an exponential growth, so it's growing pretty quickly. All right, have a great day. Talk to you later.